Hello everyone, welcome to Maxtony. Today we are discussing the topic rank of a matrix. Rank of a matrix is defined as it is the number of linearly independent rows or columns of a matrix. So if we have a matrix and it has n number of linearly independent rows or columns, rank of A is n. Rank of A we usually denote it as R of A. Or equivalently we can say that it is the number of non-zero rows in reduced form of a matrix. That means in REF, that means row echelon form, or RREF. So rank of a matrix is number of linearly independent rows or column of a matrix. Equivalently we can say that it is the number of non-zero rows in reduced form. That means REF or RREF of a matrix. So usually we denote it as R of A. And if we are dealing with a square matrix of order n by n and its determinant is not equal to 0, then rank of this matrix is n. That means if determinant not equal to 0, it has full rank. Determinant not equal to 0 means this is non-singular matrix. We call it as non-singular matrix. So for a non-singular matrix, it has full rank n. For example, here we have a 3 by 3 matrix. Let's find the determinant of A. Determinant, I am using this row to find the determinant. So 1 into finding the determinant of this matrix. This is minus 4. Minus 6, that means plus 6. Now minus, next element is minus 2, so this is plus 2, and determinant of minus 2 minus 30, that means minus 2 plus 30. Next 3 into, this is 2 minus 20, So this is, we get 6 minus 4 is 2 and 2 into 28 plus 3 into minus 18. So 2 plus 28 into 2 is 56 and minus this is 54. So 2 plus 2, this is 4 and it is not equal to 0. So determinant is non-zero. That means rank of this matrix is full rank. 3. 3 is the full. So full rank, we get full rank 3. Let's check using the REF or RREF. So I am reducing this matrix. So let's reduce this matrix. If you are confused with REF and RREF of a matrix, please check my previous videos. So, to make 2 and 5 0, I am using the operation R2. R2 changes to R2 minus 2 R1 and R3 changes to R3 minus 5 R1. So that this matrix is equivalent to 1, minus 2, 3. So this is 0, 4, minus 4. That is 4 plus 4, 8, minus 6, minus 12. Now this is 0, 5 minus 5. 1 minus 10 is 11. Minus 1. Minus 15 is minus 16 and this is equivalent to, now let's make this 8 as 1 so that it is easy to make 11. This 11 0. So R1 has no change. I'm changing R2 to R2 into 1 by 8. That means 0. This is 1. Minus 12 by 8 is minus 3 by 2. This is 0, 11, minus 16. Now I'm changing R3. So that 11 is 0. R3 minus 11 R2. Sorry. So my matrix is 1, minus 2, 3, 0, 1, minus 3 by 2. R1 and R2 has no change and I am changing R3 here. Here this is my operation, R3 minus 11 R2. This is 0, 11 minus 11, 0, minus 16, minus 11 into minus 3 by 2. That means minus 16 plus 33 by 2. This is minus 32 plus 33 all divided by 2. So this is 1 by 2. So this is my matrix and this is in reduced form. Not in RREF, this is REF. This is in REF. So we have 3 pivot element or number of non-zero rows is 3. These 3 are non-zero rows in reduced form. So rank of this matrix is 3. So as we get here, rank of this matrix is 3. That is, this matrix has full rank. Let's take another example. So here I have 4 by 4 matrix. So I am reducing the matrix A. First I want to make this 3, 4, 9 and 3, 4 and 9 0. So in order to reduce this to 0, I am making this 2 as 1 so that it is easy to reduce. That means I am changing R1 into 1 by 2. So my matrix is 1, 3 by 2, 4 by 2 is 2, 5 by 2. Now R2, R3, R4. Now I am changing R2, R3 and R4. So R2 and I want to make this 0, 0, 0. So R2 changes to R2 minus 3 R1. R3 changes to R3 minus 4 R1. R4 changes to R4 minus 9 R1. So R1 has no change. This is 0. 4 minus, this is 3 into R1. 4 minus 9 by 2. 4 minus 9 by 2 is minus 1 by 2. And 5 minus 6, this is minus 1. 6 minus 15 by 2, that is minus 3 by 2. Now 4 minus 4 R1, 0. 5 minus 4 into 3 by 2 is 12 by 2, 6. That is minus 1. 6 minus 4 into 2, 8. That is minus 2. 7 minus 4 into 5 by 2. That is 10. 7 minus 10 is minus 3. Now last row, 9 minus 9. 0. 10 minus 9 into 3 by 2, 27 by 2. 10 minus 27 by 2 is minus 7 by 2. 11 minus 9 into 2, 18. 11 minus 18 is minus 7. 12 minus 9 into 5 by 2. 12 minus 45 by 2. That is minus 21 by 2. And now I'm making this as 1 and all this integers, that means I am using the operation R2 gives R2 into minus 2. So that this element is 1. This is minus 1 by 2. So I am multiplying with minus 2 gives this 1. And I am multiplying R3. R3 gives R3 into minus 1. So that it is 1. So R4 gives R4 into minus 2. So we get all integers in R2, R3 and R4. This is R1 and it has no change. So R2 into minus 2, 0, 1, 2, 3. R3 into minus 1, 0, 1, 2, 3. You can see that R2 and R3 are same. So these are linearly dependent. Now R4 is R4 into minus 2, 0. So 7, 14, 21. So it is visible that R2, R3 and R4 are linearly dependent. R2 and R3 are same and R4 is the multiple of R2 or either R3. Means if you multiply R2 with 7, we get R4. That is, now we can use the operation R3 gives R3 minus R2. Let's minus R2 and R3 and put it in R3, and I am making R4 as R4 minus 7R1. So that R4 also 0. That is, this matrix is equivalent to R1 has no change, R2 has no change, R3 changes to R3 minus R2, that is 0, 0, 0, 0. And R4 changes to R4 minus 7R1. This is 0, 0, 14 minus 14, 0, 21 minus 21, 0. So we get two non-zero rows, 2 0 rows. The number of non-zero rows in reduced form is 2. That means rank of A is equal to 2. That means determinant of this matrix is 0. So that it doesn't have full rank. So rank of A. Now, here we use reduced form. Here we reduce the matrix A to find the rank of this matrix. So we get the rank as 2. Number of non-zero rows in reduced form. Either you can use REF or RREF. This is not in RREF. If it is in RREF, this might be 0. Means pivot element are the only non-zero element in pivot columns. So this is in REF, not RREF. So in RREF, we have 2 non-zero rows. So rank of A equal to 2.